Okay, I know that there's a 4 there, but this is problem number 5, I think. I want you, and this one kind of steps it up a little bit from the other ones. I'm going to give you a little bit of a hint if you want it. Um, but I'll let you know before I'm doing that. I want you to find the volume of the region inside the sphere x squared plus y squared plus z squared equals 9 that has a radius of 3. And outside the cone, z equals 3 minus root x squared plus y squared. Now, you're definitely going to do this with cylindrical coordinates. The question is, what are all the bounds and what's everything look like? I encourage you to, if you want to try it without my hint, um, to draw this and see if you can draw, based on what we've done, you should know what that cone looks like. You should know what a sphere looks like with radius 3. Um, see if you can draw it and figure out what it looks like, and then use that to get your bounds. All right, so hopefully you tried that, and if you just want to see my picture here, then we'll go there. Boom. You should see this, right? So it's the top half, right? Like that circle down there. I didn't want to draw all the axes because I couldn't put too much stuff in there, right? That circle down there is the XY plane. This would be the cone right there, and I've got a couple pieces there. I guess I could have drawn another little circle there, but I didn't want to draw too much confusing stuff, right? And then you can see the sphere outside. So imagine this little like wedge right here, and then imagine swirling it all the way around 360 degrees. That's the thing that we're finding the volume of. So now I think you should be able to at least give it your best shot at this point. Um, so hit pause, try it. All right, so I'm not gonna lie, I was proud of myself when I got to the end and I saw that I had the correct answer. The answer is 9 pi. I'll go up a little bit so you can see the work that I did, and then I'll walk through it, talking about everything. Okay, so I think it should be clear that theta is going to go from 0 to 2 pi. That's going to be the whole thing. When I go vertically on the z, like let me just pick a spot here. Imagine that's out in octant 1, right? Or like on the xy plane, and I'm going up into octant 1. So I'm going to go up, boom. I'm going to hit the cone, right? And then boom, I'm going to hit the sphere, right? And what's the space that I care about? I care about in between the cone and the sphere, right? So that tells me that my low z bound is the cone and my high z bound is the sphere. So that's what I wrote right here, right? And then if you think about the shadow of that, where the cone is below the sphere, that would be, the shadow would be a circle of radius 3. So that's why I go 0 to 2 pi and r from 0 to 3. From there, I got to figure out the coordinates of the cone to the sphere when I'm going up. So the cone is 3 minus this. Well, that's 3 minus r. And then the sphere, this x squared plus y squared is my r squared. So pop it over to there. I get z squared equals x squared plus y squared. Okay, so then I square root, and why do I take that thing keeps popping up and it just escape. No, doesn't do anything. All right, so I apologize. Whatever, it'll come and go. So I get z equals root 9 minus r squared. Why do I take the plus side? Because I'm dealing with a top half. If I was dealing with the, hold on, that should be a Sorry, I'm getting distracted here. That is the top half. It's the top half of the sphere. I was confusing myself and thinking that that was the equation of the cone for a moment because I have distractions in my house. Anyway, so these pieces are correct. So from here, that's all my bounds. I am gonna integrate from 3 minus r to to the sphere, root 9 minus r squared. On my z's, this r is part of the volume element, r dr d theta from polar, but now with an extra dimension. I go 0 to 3 and 0 to 2 pi. The first integration is not so bad. There, I integrate with respect to z, and there is no z, so I do z evaluated from here to here, or sorry, from here to here. So I do this piece minus that piece. That's where this comes from. From there, I was actually like really happy when I saw that because I could see this r here, and I was imagining having to integrate this maybe with a trig sub or something terrible. But this r gets multiplied there, and gives me the u sub that I want. I got a r squared, and I got a r to the first power there. So I'm gonna distribute the r in. That gives me r root blah blah blah, and then there's a double negative, so I wrote the r squared first minus the 3r. Here, I like to just do the u sub without making u's. So if you do it that way, like I did -1 over half or -1 over 2. That is the reverse power rule on this thing, right? Because I've got a 1 there, dividing by that squared. And then I bumped it up to 3/2 power and then multiplied by 2/3. If you would rather do it with u sub, then here's the u sub work for you. I'm not going to walk through that verbally, but this would be that, right? From there, 2 power rules, evaluated from 0 to 3. And now this one's a little bit different. I guess I skipped a step that I did there. The integral from 0 to 2 pi, since there's no thetas in here, I was able to just do my little 2 pi trick where I put the 2 pi up front. So this integration, it's a little bit different from the ones that we've done up until now because this low bound doesn't just zero out everywhere. And that's probably a spot where if you've been doing a bunch like the other ones, you might make a mistake. So when I plug in the 3, this piece actually zeroes out. That's what this 0 is right there. Then this guy gives me my 9, and this guy gives me my minus 27 over 2. Then when I subtract, I plug in a 0. So look, these two terms go to 0. This term does not, right? So I've got -1/3, that's this, -1 and a 3. And then times when I plug in 0 here, I get 9 to the 3/2. Well, 9 to the 3/2, square root it, cube it, takes me up to 27. And then divided by 3 takes me down to 9. So that 9, double negative, gets added to this 9, and I get 18 minus 27 over 2. Do some fraction work. These 2's cancel and leave me with just a 9, and the pi comes along, and I get 9 pi. So hopefully you either got that. If you did, awesome job. Super proud of you. If you didn't, hopefully you understand where you went wrong, and you could probably do this on your own if I gave you another one. Next problem will be its own video. See ya.